All right, let's look at example 9-61. So we have the number of calls arriving between noon and 1 o'clock on 30 days of a month. And those are all listed here. And we want to model this with the distribution. So because it's arrival rate, let's assume a Poisson distribution. And we're going to estimate lambda, we're going to estimate the average here, just by averaging up all 30 of these. So if we look at the number of calls per day and we count up the frequencies, we'll see that we have 5 calls on 2 days. We have 6 calls coming in on 2 days, and so on and so forth, with a maximum of 15 calls. So one way to start is just by using Excel to tell us the minimum and the maximum from these data points. All right, so we know we're going from 5 to 15. Now we got to figure out how we're going to bin these things. And we want to have at least 5 observations in each bin, if at all possible. So the first way we're going to do this is by making a bin that has where the first bin is for 8 or fewer calls, because that's the first place that we have 5 cells or 5 or more observations coming in. So we're going to start here, and we're going to make a bin that's everything less than 9. And now, so that's this guy, this is number 4, because we started by observing that the only bin that has more, we can't use the individual observations because everything except for 10 has fewer than 5 observations in it. All right, so we started off with this bin of less than or equal to 8. And now we can look down the list and say, okay, well 9 has fewer than 5, but 10 has 6. So those guys together give us 10. So we'll have a bin that's 9 and 10. Now we're going to keep going. 11 doesn't have 5. 12 plus 11 has 5, more than 5. So let's make that a bin with 8 in it. And then once we get past 12, we've got 2, 1, and 2, which is 5. So let's make everything greater than 12 be the 4th bin. So here are your bins over here. And we can count up the frequency of observations in each one of these bins. So we have, here's our 7, and then we got 10 in this bin, and we're going to put it over here. We've got 8 in this bin, 5 in that last bin. Now we're going to calculate our probabilities, what we have the probability of getting in each bin. So we're going to start off with anything less than 9. So I'm just going to use the cumulative probability of everything up to and including 8. So there's everything less than 9. And I put the functions over here so you can see it. For 9 and 10, 2 ways to do this. Either we can calculate the cumulative probability up to 10 and subtract off everything for under 9, or you can use the probability, the non-cumulative probability for just 10 and 11 and add them together like this. Anyway, same thing goes for 11 and 12, except here I just took the discrete probabilities of getting 11 versus getting 12. And then at the end, I just said, okay, give me everything else, 1 minus the sum of these guys. You could also just use the cumulative, 1 minus the cumulative probability of getting 12, but either way will work. So now we've got the probabilities. We have 30 observations, so we're going to calculate our expected observed frequencies. This is just 30, which is up here somewhere in 08, here. 30 times the probability, and there's your expected number of observations, 9.5. Same thing for all the rest of the bins. So 0.24 times 30 is 7.45, and so forth. So I have all my expected frequencies. Now I'm going to calculate my chi-square statistic. So I'm going to take the difference of my observed frequencies, like here we've got 7. I'm going to subtract my expected frequencies. So here I have a minus 2.5. For the next bin, I'm going to see 10, expect to see 7.45, so my difference is 2.54, so on down the line. And then to get the chi-square, I'm going to take the square of this guy divided by the expected frequency. There's the formula up there. And I'm going to get one of those for each of my bins. I'm going to add them up. So this is just the sum of these 4. I'm going to calculate my degrees of freedom. Since I have 4 bins, I'm just going to subtract off 1. So now I'm going to use 3 degrees of freedom, and I can use chi-squared.dis.right with this test statistic and this degree of freedom, and it gives me this value right here. So with a p-value of 0.49, I will fail to reject the null, and we cannot conclude that this distribution is not going to fit. So double negative there. So we don't conclusively accept the distribution, but we say we can't reject it. It's reasonable, it's plausible. Okay, the other way to do it is just using chi-test. So here I just did chi-test, and I highlighted the observed range and the expected range, and it gives me the exact same value.